Hi, this is Mrs. Jackson. This is Chapter 3, Section 4, Part 2. In this video, we're going to practice using our polynomial identities. First thing I want to do is first note the identity that you see here. What I see is a sum being raised to a power of 2. So we call this the square of a sum. And to remind you, the square of a sum, we have a plus b as our sum being raised to a power of 2. If we do all our distribution, that would be a squared plus twice the product of the two terms, or 2ab, plus b squared. Okay, let's first identify what our a and b are. So in our example, our a is 3x squared, and our b equals y cubed. So we're going to substitute this in, and we have a squared, 3x squared squared is going to be 9x to the 4th power, plus twice their product. So their product here is 3x squared y cubed. If I take twice that product, I will have 6x squared y cubed. And then finally, y cubed squared is going to be y to the 6th power. Now, if you're not completely proficient on the exponent rules, that's something that you're going to need to work out. But I always like to say, when in doubt, write it out, or at least visualize that I've got 2 of these now. Y cubed multiplied by y cubed. Kind of visualize 3 y's multiplying by 3 more y's will give you a total of 6 y's. At least visualizing that helps me. All right, let's move on to the next example here. We're going to now go in reverse. We're going to use the polynomial identities to factor and simplify. That's really where we want to get to in order to start breaking a polynomial function down so that we can learn more about its intercepts when graphed. So that's really our goal. So this first example here, let's identify what we see. We see a difference, and we see some perfect squares here. So we've got the difference of squares. And let's first write down the identity. The difference of squares says that if we have a squared minus b squared, that's going to equal a plus b times a minus b. So what are our values, our expressions for a and b? So here we have a perfect square, m to the 8th power. What's going to multiply itself 2 times to get m to the 8th is going to be m to the 4th. And for our b, we've got 9n to the 10th power. From a coefficient perspective, 3 times 3 is going to give us our 9, or 3 squared. And from the algebraic expression point of view, n to the 5th power times n to the 5th power is going to give us n to the 10th power. So now we're going to substitute in. We have m to the 4th plus 3n to the 5th times m to the 4th minus 3n to the 5th. So we can factor this polynomial here into these 2 factors. All right, next example. We've got 27 x to the 9th minus 343 y to the 6th. I see the difference, meaning subtraction, and I see perfect cubes. So we have difference of cubes. The difference of cubes identity says that a cubed minus b cubed equals that first binomial, that linear binomial, and the sign here is going to be the same. Subtraction, subtraction. So we've got a minus b times a squared, and now we want plus ab, the opposite sign, plus b squared. All right, now what are our values of a? our expressions for A and our expressions for B. 27 is a perfect cube. That's 3 times 3 times 3. So A is 3. And x to the 9th, what times itself? 3 times is going to give you x to the 9th. The answer is x cubed. So x cubed times x cubed times x cubed is x to the 9th. The coefficient 343, that is 17 cubed. 17 times 17 times 17. And y to the 6th power, y squared times y squared times y squared is going to give you y to the 6th. All right, now we're going to substitute. So a minus b is going to be 3x cubed minus 17y squared times 3x cubed squared is going to give us 9x to the 6th. And now we have their product. So we've got 3 times 17 is 30 plus 21 would be 51 for a coefficient times x cubed y squared. And 17 squared is 289. And y squared is going to be y to the 4th. All right, great. Last one. This is a numerical example. It is a sum of cubes. Now you can figure out and use your order of operations to get a final number here, but we're going to practice using the sum of cubes. So the sum of cubes, the identity says that we have a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. In this example here, what's being cubed is a 12 for A and a 2 for B. So we're going to substitute in. So I've got 12 plus 2 times 12 squared minus their product. So that'll be minus 24 plus the square of 2 is going to be 4. I've got 12 plus 2. I've got 144. Negative 24 plus 4 is going to be minus 20. I've got 12 plus 2 times 124. Instead of 12 plus 2, I'm going to rewrite that just so I can do some math in my head. That's the number 14, so I'm going to write that as 10 plus 4. It makes the distributive property a lot easier in my head. So I know that 10 times 124 is going to be 1,240. And 4 times 24 is 96. And 4 times 100 is 400. So this will be 496. So this entire sum here is going to be 6. 1,736. These are just little things that you can do to simplify numbers, especially in your head, not have to pick up the calculator. All right, so in this quick video, we practice all 4 of our polynomial identities. Again, the purpose is to break down a more complicated polynomial into its factors so that we can ultimately understand the polynomial's function graph. Okay, thanks for listening. Please subscribe. Hope this helps.